Okay. This is our new class, new content. I think because this course is called interchangeability and technical measurement. So the first chapter we just know the procedure design and we know the terms. Okay, and this class we know how to design the procedure. So how this selection of limits and fees. Okay, selection of tolerance and fees is also called the procedure design. So when you are an engineer, so you should learn how to design the procedure. This is very important for designing mechanical devices. We should find out the balance point of performance and cost. The first one, select a fit. The fit is like the 3 fits, right? Yeah. Clearance, interference, transition. Yeah. And then we select a basic system of fits. What's the basic system of fits? Yeah. Yeah. Yeah, basic, the whole basic, the shaft basic, just the 2, right? And select a tolerance of grades. Like the IT 10 to IT 18, right? 20 grades. And this class we learn how to choose that. So the method is a analogy. So calculation and experiment. The analogy we just to conclusion, give a conclusion, and then we have the experimental. Okay. Analogy method is the most used method. In some cases, if we can know the limit clearance or know the interference. Interference, we can use calculation method. For important and new device, experimental method is used. Selection of fit is to select the fit classes, clearance, interference, or transfit. So if the clearance is suitable, like you choose the clearance, you know how much of the limit clearance is appropriated. So how much of the limit of the clearance is appropriated. So this is just from the function, the path of assembly path of function, and we know how much the limit clearance is appropriated. You like the workers of function. So if the transition fit is suitable, how much of the limit clearance or interference is appropriated is also from the assembly or part of the function. So if the clearance fit is suitable, how much of the limit interference is appropriated. So analogy method is according engineer experience and the pre-existing experiences. Follow the process usually is applied using analogy method to select it. So this means that if someone give you the clearance or the interference, and then you design how to choose the class, how to choose the fit type, and then you design the grades, the tolerance grades. The firstly is determine the fit class according to fit function, and the preliminary fundamental deviation symbol is given according where every fundamental deviation features. So just the fit aptly according to the workpiece working conditions. So later I will give you some examples how to design this one. The fit function, so is the motion relatively between two works. Is like is a shaft is the shaft and is the hole. They are needed to motion or rotate very quickly. So we can choose the clearance. If the two workpiece disassembly when repairing, if the concentric procedure requirement is higher, so like this one, we choose yeah, to the IT, and this is the fit function, like the to the IT is also right, which is the function, the fit function. So if the concentric procedure requirement is higher, like to there's no clearance, right? It can to have a higher concentric, right?
So what's the concentric?
Concentric is this is the hole. This is the shaft. This is the hole. This is his line. His axis line. This is his center line. So this is the hole. This is the hole. It's rotated very quickly. So if this is his line, the other realic, or the realic, the part, the actual part, the center line is not so straight, right? So you need to vary the concentrated is this line and this line is the same line. And when he is with a high rotation, they have the same line. So if they have the same line, this need interference, right? So there's some clearance. There's no that when rotationally they don't have the same center, right? So like this, if it requires the concentric precision, we choose the interference, right? If when need some assemble a disassemble and when repairing, you can to remove the part very conveniently. So we need the transition. So when we should the function of the part function is rotated very quickly, we choose the clearance. There's no where, right? So this is the principle how to choose the clearance or interference or transition. So if the leader the rotation relatively, so we choose clearance fit, right? So it's according to the part function, working function. Okay. So if there's no motion, the did not disassembly is just to collect it very well, and we don't need to repair, so we don't need to disassembly. So we choose the interference. When we choose when we need disassembly and high concentric procedure, and we choose transition fit. When the part the need disassembly offer and the concentric procedure, we choose the clearance type. Okay, for example, so this is the rolling bearing. For the bearing, the JS is a standard. We don't need to design the bearings procedure. We just need to buy the bear, right? So it's a standard. We don't need to design that. For the reducer, the reducer. This is a reducer and gear. reducer and gear. This is the bear. So the JS7, JS6. The JS is standard. So for the bear, this is a station. The H7 for the hole, right? Yes, for the hole. The K6 for the shaft. So you know this is the transition or interference or clearance fit. H. Yeah, 7 clearance. Yeah, the H is the K is the before of the KMN. It's actually the transition. You can to find the page 28. For the shaft, the K from the basic line. So it's a transition. The transition we just use or we ask a higher concentric and also rotator or assembly or rotator rotate or assembly. Assembly is way. I think this one is related to a disassembly and to remove the part, right? And this is the same. This is the same. For this one, a shaft coupling. So this is H7 and T6. What's the type for this part? The feed this one, the feed type. H7 T6. T6 transition.
Here.
I think it's from the interference. 7 H7 T6, right? H7 is here. T. Oh, it's also 7. Transition. T here. Yeah, it's transition. I think transition or interference. I don't know this 7. 9, 7. Yeah, transition. And this is 7. 7 is now, right? This is short than the IT. It's from the interference or transition. And this one, so because this is to collect it very well. Transition. Because when we use the interference, it's hard to assemble. And this part, the crack pin and the straw is S. This is also
transition. Transition. So how's the how's here the
interference.
How is it? It's up down. Like that. Like that.
You mean how you just this is to very you can to calculate the length of this one, you know the transition or interference, right? And I just to in order to calculate is very precisely just to adjust or just to see what is the type. Now it's very precisely. Which one?
Institute.
This is just to roundly to distinguish that is the transition or interference. So for this one, this the correct thing is just collect it very well. So usually we just use the interference type, right? Or the clearance is very, very small because for the interference it's very hard to assemble that. So we use the transition, the clearance, the master clearance is very, very, very small. So the machining to basic hole A to H is clearance fit. So just to find the page 28, the A to H is an interference. The basic hole is the hole which is the H, and the hole or the shaft. When the shaft rate is the shaft is
Laoshi, can you hear me?
You can hear me?
Yes, Laoshi, we can hear you.
You can hear
Laoshi,
you.
I have problems with the question 2.5.
2.5.
Yeah, 2.5 that you taught earlier.
Example
Before
2.5.
example 2.5. Can you please repeat it again?
20 line example 2.5. The homework.
Yeah, Laoshi.
The homework, right?
Yeah, Laoshi, the homework one.
Okay, the homework. This one.
Yeah, Laoshi.
Which one? Every number or
No, Laoshi, not the every number. If you can just go through the first one, then it's okay.
class one?
You can go to the first.
The first one. This one.
For example, the 14. Up.
For this first one, right?
Yeah, Laoshi.
Okay. So the fee this is 514, right? So you can to find G7. You can to check the page 28 for the whole. This is the G, right? Find the G. I find the G.
Yeah, Laoshi.
And G. So this is the EI because the from the deviation is a line. It's a line close to the 0 zero line. So for the G is EI, right? The fundamental deviation is EI, right? This one is EI,
Yes,
right? So the value, the G7. So you can find the IT7. IT7, how much is it? How much is IT7? Hello? To find the table, 2.4. Huh?
He knows
He knows.
if he knows how.
87, 25. Hello? This is unit. So this is MM. Hello? Who? Who's the name of the student? Azar.
Oh.
Find the table. Hello?
Yes, Laoshi, I'm listening.
You listen. So how you find the table 2.4? You can find the IT7 for the 14. The diameter is 40. So the IT7 is 25, right? This is the So for the MM is point 0.025, and then you find you need to find the deviation, the fundamental deviation, the fundamental deviation value, and you find the table 2.6. So is page 34. How you find this page 34? The table for the 30. So it's G. G is the line, is the plus line. How you find that?
Yes, Laoshi,
Oh.
you can carry on. You can carry on to the next lesson. I got it.
Pardon?
Yeah, Laoshi, you can carry on from the next lesson. I got the answer.
You could
Thank you.
move forward. Okay. I continue. A match to the basket hole A to H is a clearance fit, right? The A to H is clearance fit, and the clearance value decreases gradually. The JS to N is transition fit from loose to tight, right? Because the clearance is decreased. So it's from loose to tight. This is trans fit. So this is very tight, right? And P to JC is interference fit. Interference value increase gradually. So this is hole. This is shaft. The shaft is bigger than hole, right? So it's interference. It's very tight. It's very hard to assemble because the hole is small. The shaft is large, right? And then match to basic shaft A to H is also the clearance fit, like this one, clearance fit. And the clearance value decreases gradually. JS to M is transition fit, right? So the clearance, from the clearance to interface, right? interference, and then interference value P to ZC interference fit. Interference value increase greatly. There are two basic systems of fit. They are whole basic and shaft basic, right? This is very important terms. So these two basic systems of fit is parallel from the function points. They are same. The last class will give you some example to calculate the clearance and interference of the same lane, like the T7 H7 H or H8. H is very basic grade we use for the engineer, and H7 H8 G8 they have the same clearance and same interference, right? Because they have the same name, change the position. So the selection of the basic system of fit is unconcerned with function. The factors should be concerned is cost and structure reasonable, right? It's cost. So I mean the system, like the IT, the grade, we did consider the cost. If the grade is low, the cost is very high, and the grade is higher, the cost is low, right? Because the procedure is low. So how to make a hole? Drill head, remove cutter, approacher, tool is value, fixed tool, right? One tool only machine one side tolerance the hole because this is a hole and it's a drill. So one drill just to drill the same size and the same diameter the hole, right? But for the numbers of the hole though are less, right? The numbers of the tools is less and the cost is low, right? So usually the whole basic fit is selected, but when we to machine a shaft, we just use one tool. We can to machine different diameter of the shaft, right? So usually the whole basic fit is selected, right? Because it's easier to make a shaft. It's hard to make a hole because which one type of the hole with one type of the tool, right? But it will be more reasonable using a shaft basis at the same cases. That is deviation. It just means usually we use a hole basic, but sometimes or spatial condition we use a shaft base. A shaft basis.
In the whole base, we make the shaft first. The whole base.
Whole basis.
We make the shaft first.
We meet.
We design the shaft first.
Yeah.
The whole basis.
Yeah, the whole basis.
Design the shaft first. Or we design the hole. Or we design the hole first. Or we design the shaft.
That is the relative, no conditions.
I'm asking in whole basis.
You mean that when we use the whole basis, we should to make a hole, or should firstly and or to make a shaft base firstly.
Yeah.
Also, the relative is depend on you.
Okay.
Yeah, you make a hole, you make a shaft that they use different tools, different tools. And maybe we use different laser, different machine tools. But it will more reasonable to use the shaft basis at the same cases. So which cases? Like this one. When the shaft procedure is low, it needed to be machined. For example, in agriculture, machinery, or textile machinery. Cold draw steel can be used as shaft. It's really not machined, then the cost is low. Because yeah, and like this condition, we use a shaft basis. Yeah, in the division, just to from the like the cold draw, the steel, did not be can be used as a shaft, and then we don't need any machine. I mean that the cold draw steel, you know, it like this is a draw. I don't know how to explain.
Machine is meaning like
Machine like to remove the materials.
Yeah, that's machine. Yeah, I mean, there's some sharp
Cast.
parts that really finish. Machine is
Cast, and then when you cast a machine and then need to remove the materials like the tone. You don't need the tone, you need to grind you need to milling. Like this is machining later. So the procedure is very low. So one shaft fit with more than one hose, and then fit the properties is different. Like this one, if this is a shaft, it needs to fit three holes. This one, and this one. So if we use so this is whole basic, right? This is H6. H6 is whole basic. This is short basic, right? So when we use the whole basic, you see, so this is M5 is here, M5 is here. So when we make a shaft, like a shaft, if this is the interference, right? This is clearance, right? This is interference. So the shaft like this, when the real shaft is like this. Can you understand? Right?
Yeah.
Because this is interference, this is clearance. So the real shaft for one shaft, so this is the smaller. The reality is diameter is smaller, this is larger, this is larger. So for this, like this one, it's very hard to assemble this one. Okay? But we make the shaft like this one. So we use the whole shaft. So this is the shaft this is the shaft basic. We will use the shaft basic. So this is his grade. So this is easier to assemble. This is the shaft, right? To fit the 3 holes. 1, 2, 3 holes. And another one, shaft is standardized workpiece, like this, the bell, right? The bell is a standard workpiece. In these cases, we use the shaft basis to design the hole. Okay? This means that in common condition, we use the hole basis, but in these 3 conditions, we use the shaft basis. Okay. No basis system of the fits. So when one hole fits with more than one shaft, and the hole is not basis hole, and there will exist no basis system of fit. So the hole there's a shaft with different steps. The step shaft. So this is called no basic system of fit. So when one shaft fits with more than one hole, and the shaft is not basic shaft. So there will exist a non-basic system of fit. Now this is with the assembly with the hole, and this is the bearing. The bearing is a shaft base, right? So for the hole is a hole base. So there we use the hole base and the shaft base. It's called the basic system of fit. Okay. A standard tolerance. So how to select the standard tolerance grid? The first step, we choose the feature, the feeder type, right? We choose the interference, clearance, and the transition. For the clearance, there's rotator or move very quickly. We choose the clearance, right? When we need to assemble or disassemble, or we need to remove it. When we remove the part conversely, when repair the part, right? We use the transition, right? When we repair the concentric it, we use interference type, right? But we noticed that interference type is very hard to assemble. So we just use the interference is not very large. It's from the clearance is small. Because when the interference is large, it's very hard to assemble that. So when we choose the first thing, we choose the type, the feed type, and then we choose the tolerance grade. So how to choose the tolerance grade? First thing, the standard tolerance grade is a relationship with the device procedure. It's like the function, the power function. If the function lead the high pressure, we just to choose the tolerance, the low tolerance grade, like IT7, IT1, IT2, IT3. The value is low. So it's a high tolerance. It's a high procedure, right? And the manufacturing cost. If the the tolerance, if the pressure is higher, the cost is very higher, right?
Yes.
And the manufacturing method is like with drilling mainly. The grade is like the IT3, but not IT3, IT9 to IT11. But for the grade, for the grinding, the IT is like the IT3, IT4, IT7 to IT7. So the basic principle is in the case to satisfy the requirement of application. Select the lowest possible tolerance grade. The shaft and the hole should have equal machining difficulties. In other words, if the hole tolerance grade is less than line to clearance or transition phase, less than 8 to the interference fit, the shaft tolerance grade should be below 1 grade than the hole. This means that we choose a shaft, we choose a hole. Sometimes we have the same grade, tolerance grade. For example, we make a hole. We make a shaft. We make a hole is IT is G line. This grade is 9, right? This is procedure. Procedure is machining procedure, and we machining a shaft. It's also like the H9. The word usually are the same. It means we have the same or the equal machining difficulties, right? You don't need to like you make a hole, it's IT9, and you make a shaft, it's IT1. It's not meaningless, right? Not meaningful. Because this is very It's not a very suspicious it's procedure. This is very is a procedure. It's not meaning it needs some cost, mostly manufacturing cost, right? So usually it's the same like the line and this is the line. But for when the tolerance grade is less than line or is less than 8, like 7, yeah, 7. But for the whole, it's very hard to machining. It's more harder, it's more difficult than the shaft. So for the whole, we choose the 8. Right? 8 and 8, the IT, the tolerance grade is 8, and this is shaft is 7. They have the same machining difficulties. Okay.
Actually, generally, it's hard to machine a whole
Yes.
shaft.
Yeah. But for the procedure is not very high. They have the same grade. They have the equal machining difficulty. But for the procedure is higher. The high it means that the IT is equal or 8 is a procedure. The whole is larger than the shaft. IT.
That's why delta is added because it's too high. Why do you add that delta?
Because machining a whole is difficult. It's difficult than the shaft. So we choose 8, and then we choose for the shaft we choose 7.
I'm asking why you add delta.
Add a data.
Why do you add delta to the whole when the precision is high? Because you say when the precision is 8 or less, you need to add delta to the whole.
It's less.
Yes.
It's less 8. It's we need to add a data. Right? Break. Okay.
Guys, that was my job, guys.
Okay. 10 minutes. 10 minutes. Okay.
Today class ends at 12. Don't worry. Class ends at 12.
10 minutes,
My
right?
question.
The question is,
You add delta.
we add data to whole, right?
Guys, it's break time, okay?
Why?
Break time. How do you 7? Maybe 8. Maybe 9. This is okay. Okay. No, sorry. Maybe this is
So fast.
so this is 9. Okay. Because this is whole. Equal to machine. And then this is sharp.
Usually we just learn a 1 grade.
Yeah, so this is low. I lower this one.
Yeah,
Okay, so
it's
6.
yeah, it's 1 grade. Usually.
In your machine, I'm lowering here. We still add the
Machining.
not machining.
Mm,
When we are designing the
yeah, design the whole.
we add the
I mean, design the whole, not. Let's list a term that we design the whole. When we calculate the current, we add the data frame, the current, we add a data. We add a data, the clearance is, we add a data, the purpose is to have the same grade like the H7 or G7. But in this, yeah, this one. But we don't use, this is not very usually used. We're not usually used because the hole is low. Then we don't design like this.
Actually, the clearance, say clearance is when
clearance. This is clearance like this one. This is sorry. This is the shaft. This is very clear. What's the clearance?
So that's the interference.
Interference like this one. This is the hole. Shaft. Here, this is have some crop. And
Transition.
this is transition. Sorry, this is the transition. Clearance. Interference like this. This is the hole. This is the shaft. Most of the shaft is the lowest shaft is the largest hole.
Okay, so in this the shaft is up, it's interference.
Yeah. Yeah.
Okay.
But this interference is very hard to assemble because the hole is large, the shaft is hard to assemble that.
Èyí mẹ́mẹ́mẹ́. What level? ¿Cómo está? ¿Cómo está? 老师，要在。
She just did now.
Oh, it's fine. I will just check how much I need to work. Fine.
Silly guy to bring a cup. No cups in class. But she will be the one to teach us the practical next. Will be the one to teach us practical this year. Practical. Loud. No level. Next week or next week. It is there left. Really. She said before we don't have any left. That's. So you making shaft and move. Actually, no, we're doing shaft and move. So we are going to measure. We are going to measure. Machine.
Machine is the laser code. For the vendor, final vendor, on the factory. I don't think that the YouTube that the YouTube see possible.
Why do you want to see? Why do you want to class?
But it's dangerous and you said it.
Actually, maybe we think something that's in the phone. Then we can take it. Yeah. Team souvenir. Every day I will. Oh, that's my home. Why am I? Oh, information.
Maybe.
Oh, there are too many shops now. Your last thing is starting with the shop. We tested the shop. Yeah. Where? Where? Yeah, but you are yeah. But only this one. Yeah. But you are engineering. We did a 10,000.
Yeah.
Yeah.
Like,
Yeah.
like something,
The shop.
like something.
Did you by yourself?
Yeah. Yes, but what's interesting? It's not.
Everybody yourself.
Yes, boss. It's hard.
I didn't, bro.
It means
Suhan.
we did laser, right? Laser and laser test.
Yeah. Some teachers
Yeah.
teach you your future.
His name was Blue, right? Blue House, yeah. Engineering materials.
Yeah.
Blue House, yes. You know, you got teachers. So sad. Yeah, it's in it's studying in Hong Kong.
Yeah.
Yeah. Actually, no, see, online view.
Okay. Kilo class.
It's not class.
Back to your seat. Continue the class.
关注吧，你们的上课上。
上课。Also, continue. And we how can we to select the standard tolerance grade? So there are some examples. So for the IT09 to IT1 used for memory block, this is for the standard block. Like we use the block to measure something. So it's in this block with a very high precision, right? Because this is a memory block. So IT1 to IT7 used for memory gauge with memory shaft and hole of IT6 to IT16. This is for the memory gauge, right? Memory gauge which memory the shaft and the hole. So standard gauge. So IT5 to IT12 used for fixed sizes. So IT5 to IT6 used for spindle or precision machine tools, a piston pin and piston hole of combustion engine. So that is a very common example. So IT5 to IT6. So IT6 for shaft and IT7 for hole in the machinery. So for the shaft is low grade, right? For the hole is a higher grade, 1 grade. So IT7 to IT8 used for mid procedure requirement. Usually, if for the engineering, we just use IT7 to IT8. So IT9 to IT11 used for general requirement. IT11 to IT12 used for no important fit. So in this one, just how to use how to choose a grade, right? How to choose the grade, it depends on the function or the requirement the requirement you need. So IT 12 to IT 18 used for non-feed size, just for the shaft and the hole, no feed size. So this is the tolerance grade obtained from different machining methods. So usually we just use tooling. Tooling, this one is IT7 to IT11, the tooling procedure. The boring is also from this one, IT7 to IT11. Usually when we use the tooling or boring method, the procedure is IT7 to IT11. The milling is the same. The plane and the thrusting so is 10 to 11, and drilling is also, but for the grinding, so it's higher, is 5 to 8, right? And the drilling, his procedure is low, is 10, so here is 10 to 30, right? The drill, the procedure is not very high. Yeah, that is very common method. And get the tolerant grade.
Do they ever use lapping?
Lapping.
Do they ever use it very rare?
No, this is very higher lapping. Only is also. I think it's very not very common to use that one. So if we require the part require very high precision, we use the lapping. More usually we use when we to machining or higher method, higher part, we use the grinding. The grinding is common use. So this is very common. It's very easy to understand when the procedure is very higher, the cost is very high, right? The procedure is low, the cost is low. So this is the relationship between the relative cost and the tolerance value. So the recommendation phase. Do you have a question, online student? Hello? Okay, this is common. It's a recommendation phase. It's usually when we design the shaft and the hole, we choose this one. This is emphasize this one. Usually we choose the emphasize values. Okay, the values like this one. We choose this one. This is very standard value, standard phase. Okay, the standard phase we choose. If we relate to design a tolerance for the IT7, we choose this one. So for the basic hole, the whole basic IT7, we usually use IT7, IT8, IT7, this one, and the shaft low than this one, right? And for the 8, they have the same. And the line have the same, right? The 11, when the procedure is low, they have the same procedure shaft and the same procedure and the same hole, procedural hole. Okay. So when we design the shaft and the hole, you can choose the grades from this table. The recommendation phase is the first use we have the emphasize value. Okay.
Yes.
And then for the whole basic, we can use this one and this one. This is the first link we choose. preferred fit for the clearance fit H11 or C11 or C8 to have the same interference. Sorry, to have the same clearance. And the maximum of the clearance and the minimum of the clearance is the same. Just change the number. This H11, this C11, this is C11, this H11, right? Just change the position or change the number. They have the same maximal interference and minimal interference. So this is for the loose running fit. It's running very quickly. It's loose fit. For me, it's large clearance just for assembly free, allowing the use of the parts with a high temperature during working. When with a high temperature, yeah, the part will grow large, right? So we use this IT grade, this grade, H11 or C11, the loose running fit, and usually used in pivots, lasers, fits. A part is processed to corrosive effects, contamination with dust, and thermal or mechanical deformation. So it's like the part can deform a lot, and then we use the H11 and C11 loose running fits, and the H9 and the D line. So this is a little higher than this one, right? The pressure higher than this one. This is for free running fit, not for use where accuracy is essential, but good for large temperature variations, high running speeds, or heavy joule pressure. The free running fit. They use multiple feeds of shaft of production and piston machines, parts rotating very rarely or only swinging. This pressure is higher than this one. This is for the deformation a lot. So H8 or F7 or F8 or H7, the closely running fit. For running on accurate machines and for accuracy location at a moderate speed and joule pressure. Because for this function, for this example, they use a accurate location, right? Accurate location. And also you can rotate a speed, rotate or moderate speed is rotated not very quickly. So main feature of machining tools, general feet of shaft, regulate bearings of machine tools, spindles, slice rods, the machine tool spindles. So just to accurate machining, can running accurate machining, and for accurate location is require the location, accurate location, and also require the rotate. So we use the H8 F7. For this one is very common used in engineering. For the H7 G6 is sliding fit, like the precision part, operating at slow speed and light loads that must run freely. So the clearance, a change in the elite clearance, change in temperature may cause difficulties. Running fits with very small clearance for accurately guiding of shaft without any noticeable clearance after assembly. Part of machine tools, sliding gears and clutch discs, crankshaft, jollers, pistons of hydraulic machines, rods, slides in bearing, grinding machine spindles, So this is also use a higher position and a rotate and a split, not a low speed. It's a slide speed, a low speed. The H7 to H6. So this is the basic whole and basic and short basic. The locational clearance fit with very small clearance for precise guiding and centering of part. So a very small clearance, a center of the part, mounting by sliding on without use of any great force. After lubrication, the parts can be turned and slid by hand. Procedure guide of machines and preparations exchangeable wheels, roller guides. So and for the part, firstly you just to analyze its function and to according this method, according this experience, and then to choose the grade, the fit type, and then the grade tolerance, the tolerance grade. For the transition fit, the clearance is slow, and the interface is also is slow. So like the H7 is K6. The location transition fit is also we need to collect it or location transition fit. Similar fits with small clearance or small interference. The part can be assembled or disassembled without great force use of rubber mallet. Demountable fits of harbors, of gears and pulleys, manual wheels, clutches, or brake discs usually used in here. So H7 and 6 locational transition fit. The fixed fit with negligible clearance or small interference. Mounting of face use pressing and light first. Use fixed plugs or drive bushes. Armature of electric motors on shafts, gear rings, or flashers balls. So when you need to design the part used in these conditions, you use the H7 for the hole and N6 for the shaft. For the interference, it's H7 is P6, locational interference fit. For where the small clearance or very or small interference, just for the location position. The locational is to make the position is very here, not to remove. For parts requiring rigidity and alignment with prime accuracy of location, assembly of the parts can be carried out using cold pressing. The harbors of clutch discs or bearing bushes. The H7, H6 or middle drive fit with middle interference. Assembly of part use not hot pressing. Assembly use cold pressing only with use of large forces. So the large forces is to drive fit. Middle drive fit, 然后为了去transfit a large force. Permanent coupling of gears with shaft. So in this one, we don't need to disassemble that, right? It's a permanent coupling gears and with shaft, a bearing, bushes. H7 or U6, the first fit with bigger interference, suitable for parts which can be highly stressed or for shrink fits. Assembly use precise and great forces under different temperatures of the parts. The permanent coupling of gears with shaft or flanges. Where for the permanent coupling will usually use the interference because we don't need to disassemble that. And when we in this class, in this one, we lead how to choose the feed type, right? And how to choose the grade, right? With the function, how to choose the grade. And the purpose it means that how do we design the pressure or design the tolerance or the grade of the tolerance. So how can we design that? So there are example. If like this one, a hole based fit, a basic size is diameter is 40 millimeter. Permissible clearance is 75 to 210 to calculate all the fit symbol. So how do you know, or how do you choose the fit symbol? It means that when we give you this one, and or your boss give you a part design part or function, you need to design the grade, or design the tolerance grade like this one. Usually we use the whole basis, right? So the give you a basic whole is 540, and the permission is clearance, like you can remote it very quickly, and the clearance is 75 to 2010 And how do you choose? How do you choose the grade? Or design the grade, design the tolerance grade. It's already give you the clearance, the type, the fit type, and then you choose the how do you to design this the fit, the grade. Like you give your boss is like the G7 or H6, like this one. Or you H7. Oh, this is sorry, this is whole. G or H7 or H8 or G or M7 or M8. Like this one, how do you choose which one?
Which one about?
This one. I mean, that's example. Choose the from the table. Which one from the table 38? Or just choose which one? Or design the grade. Can I give you some tips? Do you remember this question? TF equals maximum clearance balance minimum clearance, right? It means that this when a shaft and a hole assembled together, they can move range equals TH is the tolerance of the hole and tolerance of the shaft, right? For fit, as TH equal TS, or tolerance of the grade is low one grade than tolerance of shaft. For the hole and the shaft, usually because it's needed to repair or to make sure they have the same machining difficulties. They are the same grade, right? And for the low, the high operation, they have the whole pressure grade is low, 1 grade. Then their tolerance are shut. The
That's the condition for feet.
condition for fit.
For feet.
Condition.
Yeah, this tolerance hole is lower than tolerance shaft. That's the condition.
Not the condition. This is the principle how to design the grid. Yeah. It means that one condition is equal, or when it's a high grade is low. So when you choose the IT is 8, they have the same. When you choose E7, maybe the shaft, the hole is low grade of the shaft. So it depends on which grade you choose.
The tolerance gotta be the same.
Hmm?
The tolerance gotta be the same.
Yeah, the same. Think about that. You 5 minutes to think about that. 5 or 10, 12 minutes to think about that. How to design the grade.
The tolerance of solvent and calculate less than.
Now the condition, I think that if you choose the IT is 8 and they are equal, right? If you choose the IT is 7, maybe the shaft grade is higher, one grade than the low. Yeah. It depends on what the grading choose. It depends on the condition is the condition is the base size is 14, the diameter is 14, and the permission clearance is past 70 to 100, 210 is the condition. Only new condition related to design the big statement. Design the feet. I also really tell you the clearance.
Well, actually, I can choose any seat I want, right?
Yeah. You can choose anything if you there have a reason. It's fine.
It's clearance.
Clearance, yes. Clearance. Is maximum clearance and minimal clearance.
How to use this? How to use this permissible clearance compared to non-set?
How do you use that? Is that the minimal clearance is the
Minimum.
yeah, right? It's from here to here, it means that the vacuum is lower than that. Permissible, so here it's 75 to 208 is the clearance. If this is short, this is the whole clearance. Move this clearance, but also it's lower than that. The maximum clearance is low there. If the maximum clearance is low, then 200 if the minimal is not. The 75 is the range of is that the range is
That's why I did that. So,
it's okay now. You can relax, but feel the reason. It's the interesting. Wow.
and it helps you.
Yes. Yes. This is the cat. This is the key. This is the cat voice. Yes. This yes. Right. Yes, yes. This is the from 14. The maximum, the 减 right? 减 yeah, because 14, wow. I got a vision. What is the maximum? The maximum here. But when you design this, what is the maximum here? You possibly belong. Given that from the about two or it will be very great here. Thank you. Yeah, and the provision of the is 35 times the same. You design the grade is
should change the here.
I think you did this.
Okay, I think how to do that? Can you explain?
What is it for?
Okay. Okay, just listening very carefully. I think it's a little mixable. Okay. So a whole basic fit, the basic size is 40 millimeter. Permissible, its clearance is 75 to 210 So you just to design the grid. His permissible clearance is 75 to 210. So if this is if move, the clearance is 49 to 209. So if the clearance is here, is right, it's okay, right? So its clearance is here, is okay. Maximum is minimum, is okay, right?
Yeah.
But for this one, it's very high pressure, right? You need a cost with more, right? So you need to design a clearance like it's close to 210 and close to 75, right? So for this one, the manufacturing cost is low, right? The lowest, right? So that is the principle. So the permission clearance it means that if the minimum x mi equal or 79, no, equal or large 75 is okay, right? Right? And the x maximum is large or smaller 301 is okay, right? So how to design or how to calculate the x minimum? You know this is the whole base. Whole base is means that the whole is here, right? This is the whole. The clearance, the shaft is here, right? This is 0, right?
Yeah.
So how to, and also there's a large equation equally when we design the tolerance, the grid, the core and shaft is equal, right? It means that the TH equals TS equal, right? And this is the maximum is this is TH equals maximum y maximum equals the y minimum. So is what
1 chain minus 75.
1 to 5
Cost
6 right? 5
2, 8.
3 right?
35.
Right? Right?
Yeah.
So this is equal and the TH equals TS or TH equals TS, right?
Yes.
Right? So this one just the equals the IT 8, right? For this, sorry, this THIT larger than 8, right? This one is IT equals 8, right? Right? For the high pressure, the hole is low than the shaft. For the when the IT large 8, they are the same grade, right? So we'll choose. So this is the IS. Is this one, right? Oh, when it's equal, is this one, right? I choose the table. 27. When the IT is low, there's a 67.5. Is choose the table. You don't understand?
No, I understand.
Understand? Okay. You choose the table. So which one is local? Is smaller than this one? 27. Page 27. IT
40, 46.
40, yeah.
Plus 6. I should use the IT 62. IT 1. IT 9. I should 10. 9. 10. 46. Yes.
IT line. Why is it plain? I don't know.
That's it. Learning for maximum.
Mean is local, is smaller.
Small IT.
IT line, right?
Yes. If it's less than IT.
IT line, right?
IT 9. IT 9.
Right?
Less.
Everyone understand? IT line?
If it's less.
Less. Oh, it's less.
8.
Okay.
IT 8.
IT 8.
Bro, D is 40. So you need to go there.
Less than this smallest number. Okay.
Yeah, 67.5.
62, IT 9.
That's same number.
Which IT line, right?
Yeah.
Yeah.
Right?
I don't get it.
I don't understand. So this one understand, right?
Okay, how can you go this 67.5?
This one. How get that? This one. You mean that? So you mean that how to get this one?
Yes, Lash.
No.
What equation?
Lash, why did you choose 135?
We choose one what?
Choose 135.
No, this
37.5, right?
Lash, 135.
This one.
Why did you choose that?
This one is this one maximum minus minimum.
minus 75.
This TH is, do you know this equals?
Yeah.
Understand?
Yeah.
This equals. So this equals, this is minimum is here, maximum is here. So this one is smaller than this one, is 100 to minus 75. Right? So the clearance is here. I mean that we designed the clearance is like this one, right? It's smaller this one. It's right. It's smaller this one. The cost is the smallest. It's very low. So this one is okay. The pressure is higher. So the method, the manufacturing cost is higher, right? So we design the grade is smaller to maximum and larger, at least larger than the minimum. It's okay, right? So do you understand this one?
Yeah.
Continue. And we get the number is 67.5 and choose the table 2.4 is we choose IT 9, right?
9 and 10.
Oh, sorry. At 9, so the at 9, so it's equal, right?
Yeah, 4.
So the shaft is also at 9, right?
Yeah.
Because this is larger than 8, right?
Yeah.
So we choose for the shaft and the hole. We choose the at 9, right? Sorry. And then, and then for the hole, the I equals 0, right? Because this is whole basis, right? Whole basis. So this is the line. So we use this line. This one. How is this one? 0, 0, 62, right? This is okay. Use is for right? Right? But IT line is in line. Right? Understand? You can choose to shaft IT line, which is IT line. So this is the whole basic. So EI equals 0, right? So yes, you choose the IT line. ES equals EI plus TH, right? TH is IT line, right? So is plus 62. UM
But we choose IT9 because at 40 to 74 you get 114.
114.
Choose IT9 because at 74 to 40 you get 114.
What do we get 114?
IT9.
IT9. This one. 62.
Choose IT9 because why do you that?
Why we choose IT9? Okay.
67.5.
Okay. So this is you understand, right?
Yeah.
And then for speech, so we choose the grade equal the tolerance, the whole and shaft have the same manufacturing method, manufacturing difficulty, and have the same manufacturing difficulty, right? They are the same grade, equal for the common have the same grade, but when the whole the grade is low or equal than 8, and the whole is lower 1 grade than tolerance shaft, right? So it's like the TH equals TS, right? Or the IT for shaft is TH, right? IT they have the same IT, they have the same tolerance, right? Right? That is the TH equals TS, or TH plus 1 equals TS, right? Is the ITH. Then the ITH plus 1 equals ITH, right? It's this one, right? So they have the TIT plus H, this IT large H, right? Right? So if TH equals TS, is we can get TH equals, right? The TH smaller or equal 57.5, right? You got this one, right? And you check the table 27. Which one is equal? 67.5 for the diameter is 40. Check the table. At 9, right? So this is at 9. The at 9 is larger than 8, right? So we choose this one, right? So we choose at 9. For the shaft and for the hole, they have the same grade. So we also choose 89 for the shaft and for the hole is 89, right? And continue to 89 for the 89, the TH equals 32. TS is also 32. Oh, 62, sorry. Right? So the IT and then we choose. So and then this is the whole H line, right? H line. So the shaft is also 9, but this word. How can we choose this one, right? We should choose this one, right? So this is 33, the maximum. So the maximum is here. The tolerance, the TF, the total tolerance is 139, 139, and minus this one. So what is that? TS balance smaller or equal 3, right? So you can choose. No, sorry. Maximum, not this one. You have to see. You have to see. And this one. And we go this one, right? We choose this one, right? This one is the EI. This is the ES, right? So the ES equals, sorry, EI minus ES. This is the minimal clearance, right? This is minimal clearance, right? The minimal clearance is larger than 75, right? So this is 0, right? ES minus 70S, because we can check the table, we can get this one, this 9, right? This one we can take the table, we can get this one, right? Right? This is for the shaft.
Yeah.
This is the 9. This is the 9 is the IT line. We choose this number. So this one is ES larger than 75, right? So take the table. The ES larger than 75. Which one? Yeah. Table. The table 2.5.
Shall we say for I? Okay, result of the AI of the shaft. Yeah.
Balance. No, sorry. The balance. Oh, sorry. It's balance, right?
Minus. Yes.
Yes.
But even they say this one you would.
It's balance in here, right? Balance.
Yes.
Right?
But we can see.
Here.
No, I think D
D.
is better.
D, right?
Yeah.
D is better, right?
Yeah.
So what choose D? Got that?
How?
Huh? How choose D? D is yes,
Greater.
smaller than
It's smaller.
Well,
Smaller or greater?
D.
Smaller.
Smaller.
Ah,
Yeah. Is D, right?
Yeah.
You understand D, choose D?
Yes. Oh. Please, minus 3.
Amazing. This is difficult to design, right? Because the previous numbers you didn't know. The previous numbers.
Okay. Yeah, D actually minus 3.
Do you understand?
Yes.
Can you understand this one?
Yeah, I understand that.
You understand this one, right? So you take the table. Shaft is 32, right? So the diameter is 40. Choose the 49. The 40, this line is 40. Line is 40, so is smaller. Minus 79, 75. So you can choose minus 80.
Minus 8.
Yeah, is need the requirement, right? So the 80 is D,
D.
right?
Yeah.
Is D. This is D for the shaft, right?
Yeah.
So this is minus 80, right? Yes. And this one,
Minus 89.
80. Oh, 89, okay. This is 89. The TH,
89.
TH equals 23, okay?
74.
It's
So is
2 minus
balance 1,
42.
yes, balance 142. Right?
Makanya semua.
Also, my question is the time of code H9. Why you start from 0?
This is 0. This is the whole basic speech.
That's what.
Whole basic is means that is H. This is 9. This is very basic. Now, in the break, okay. In the top. Huh? Yeah. Where?
This be I.
Which? Yeah. Yeah. You can do right. This is easy.
Close. Yes.
Ah,
No, man, please, man.
this is you and me. Okay.
You think it's not?
Marcel.
Yeah, and then we choose to check and leave the requirements for us. Then
If I see.
Yeah.
H.
Or
Yes.
the
yes.
Wow.
clearance knowledge.
Yeah.
Okay.
Yeah. Speed. So I think this is how the question.
So the question.
This is how the question is for the variation
This is question or not?
in scope performance for the variation. Or you will add.
There will be the format. Later. The 11
And
will start on.
yeah. It's great. Yeah.
Not in the break. Not-
Exactly. It's great.
Yeah.
Let's take a break. Let's take
It's almost.
Let's break that at 11.
A break is
Yeah, just,
that is 11.
yeah.
But you say it's a break.
You.
You see,
It's very long. Go break, go out.
Gone?
You.
You have question? And here is age. Yeah. So this is a whole basic piece. Is a whole. Is a whole. This is not or this is a full basic piece. Okay.
Another example.
No, I shall write.
Okay. So this is the whole basic. Okay. This is the whole basic. It means that this is zero. That's for the we have a combo. The two basics. Basic systems is the whole basic, is short basic.
Yeah.
Mostly we use the whole basic, right? So the whole basic is the whole. We choose the H is the whole basic. So this is the whole basic. So this is a zero, and the ES we use like the IT7, IT9, IT10 to determine the ES, right? To determine the ES. So this is the IT line. So ES is plus 62, right? UM. So like this one, the AH is the clearance. This is the transfit. When this is the whole basic, it means that the whole is fixed, and we choose will vary the shaft of the shaft grade. Or shaft this one. The shaft words, values, or tolerance, or shaft A to H or Z to H. The shaft deviation, right? And then there's interference. For huh? Only for the H, yes. Yes, the H is fixed only for the H. This is a whole shaft, it's a whole basis. And for the shaft basis, this is the shaft basis. It's like this one. We fix the shaft and remove the hole. Right? For the hole and the shaft, they have the same things. I mean the clearance and the maximum clearance and the maximum interference they have the same, right?
Yes.
And mostly we use the whole basic, and in these conditions we use the shaft. Okay, got.
I will.
Break or continue?
2 minutes more. Break is 11 o'clock, please.
Break is already finished, bro. How much does it mean?
Yeah, break start at 11 o'clock.
Okay, this is our format. So according to the givers, the maximum clearance is 210, right?
Yes.
The minimal clearance is 75 UM. The permission variation fit is TF, right? TF is maximum minus minimum is 135 UM. So equal the standard tolerance grade since IF equals TH plus TS and TF divided 2 around 67.5, right? To the equal. And look up table and find IT line equals 62, right?
Yes.
And the whole tolerance grade is ID line, and because the whole basis means that the H line, right?
Yeah.
So the sharp tolerance though symbol, the fundamental deviation is upper deviation for shaft is the whole basis. So the minimum of the clearance is minus ES, right? So minus ES equals around 75. So it's larger than this one. This is the minimal clearance. The minimal clearance is a large 75, right? So we check the table 2.5. We know the nearly equal 75 is D, right? The value is equals minus 80 UM. So the symbol is D line. Then the low deviation EI is 142 minus, right? And we check the minimal and maximum. The standard the limit clearance is maximum is EI equals ES is plus 80. So it's large X minimum. So it's okay, right? Is satisfying the requirement. The maximum is ES minus EI equals 210 or 204 is smaller 210. So is meet the requirement, right?
Yeah. But the answer to have been first or second.
The second bracket.
The standard limit clearance.
The standard limit clearance. The standard limit clearance, right? Is maximum EI equals ES. Yes. Yeah, so is the line is the 75 satisfying the I'll give you examples later. And then
Yeah, we
Please think of the question. Please think about the question. Dream about it.
the follow test will give you like the answer question and you yes
And
the
answer.
answers.
You give out the question and the answer.
You just answer.
Ah.
And you just to solve it.
That's it. How about you give out the question? Solution. Yeah, we can give you how to answer.
How to get the answer.
Yeah. Yes. That's it. The example. Only it's allowed to
Look, I agree.
Schedule me.
Save my WeChat to come. Wow. Right?
I'm just calling you champ.
You answer this one.
Understand this one.
one is this one.
Yes, but this line.
This one, that line, this one, that.
I think it's too easier to measure and the real is the not yes.
Oh.
This line not.
Now,
This one. Yeah.
this one.
I don't know the students online understand or not. I think I'm confused.
Yeah.
Can see.
Yeah, so you can
Ask.
take random one then ask. You don't understand.
Do you understand the
Yeah.
exercise?
I hope them.
Also,
Yeah.
Agora está o
yeah, for example.
Little confused. Confusing. Not difficult, right?
It's not difficult.
It's just
It says
everything confusing.
Confusing. This one?
Yeah.
Confusing. I think everyone understands.
That's it.
Everyone.
Oh, not everything.
Okay, you all, it's not your thing.
I hope.
I think everyone can understand. I hope everyone can.
I hope. I think.
Yes.
I hope. I hope everyone can understand. Okay.
Yeah.
But I think they cannot understand. Confused. Easily.
It's a break, right?
Yes.
You wanna mute?
Mute. No.
Why not?
আবার গাড়ির ব্যাটারি আনতে হবে না? গাড়ির ব্যাটারি
I'll continue our class. You have any question?
দাদার মনে হয় ফ্রেন্ড কয়েকদিনের জন্য না, আমরা গাড়ি আনার আগ পর্যন্ত 3-4 দিন রাখতে চেয়েছে। দাদার একটা বন্ধু আমার মাসে থাকে ওর গ্যারেজে, দাদাকে গ্যারেজে রাখতে ছিল 4-5 দিন। ওর গ্যারেজ খুলছে তো আমাদের সাথে কয়েকদিন রাখতে।
বন্ধু ক্লাসে এসে
হ্যাঁ হ্যাঁ
Continue. Continue. Just give you an example. And your chapter basic speech. Yeah, this is the short basic. Okay, this is h, small h. The basic size is 516 millimeter. For millimeter, maximum clearance is 12 UM. Maximum interference is 20 UM, minus 20. You got the feet symbol. You try, think about that.
Yeah.
Follow the previous steps. Follow this, okay? 10 minutes is
What
okay?
about this maximum interference?
Yeah, this is maximum interference is
Minus
20.
So what does
The
it mean?
clearance is 12. It's the same. This is the move range, right? So this is balance. This is the clearance. It's the same. The total, the length is 22, right? Oh, 32, sorry. The same, right? Ten minutes. 10 minutes is okay. Depends on. You understand it or not?
Maximum clearance.
Maximal interference, yes.
So two different solutions.
What?
Two different solutions. I don't understand how.
Understand? Yeah, it's a transition.
So
Fit.
one is X, one is Y.
Yes. It's the same. Okay.
Yeah.
Let me. And this the equation, remember the equation is the same. This is the maximum, the clearance. This is the transition.
Maximum interference.
Yeah, this is the interference. So this is the same. Is the maximum balance. Maximum interference.
Question.
Question. Okay. Oh. Check. Oh. Think about how to get the call. How to calculate the next one, the next one. Here, this one. How to calculate the depreciation and next one. So how to calculate the calculation here? Equation, how to calculate the from whole from the yeah, yeah.
So, yeah. Yes.
Yes, this is a yes, right? Yes, not this. This is yes, equal to balance below the line. This is your yes, this is your yes. This is yes, right? Value yes, balance 11. This is a yes. Yeah. Yeah.
So, here you go. Understanding. So the whole is here. Can you find yes. PH for then PH for
Can you just think about this? The axis, is the shot to that because for the whole is equal line there. For the whole right, and you get the 6 right. As for the whole, maybe it's a 6, maybe it's a 7.
6. So like 2 PH plus 8 should be same.
As for the if you get it, you can see this one, right? And then you keep it. And then you calculate the next step and you. Yes. Then, no, okay. Step derivation, because the spot derivation, and the rate. That is for the soil. And you can choose the number. You just choose the number.
Yep.
You do this one, how is it choose the number? Oh. This is 11. Okay, right?
Okay.
You need to take here, and you get the answer. It's this one and this one.
Minus 20.
And the number. And this one is also very rare result. That's wrong. 这个有个去的 number clear， clear is yeah. Which city right? Please TS is no the TH 发填一设计。Yeah. Yeah. Yeah. Check it. Dann halt die Level und dann is there you need to this is a wrong I mean that this is right the maximum experience is right this is wrong I mean that is here, but we need even more range that the that the is wrong. Not here. Here one that is more than one. 18, yeah. This one the top graph this is the rear graph the top here so this is 11 this is IT this is the that and they design the whole and then design the whole. The whole is the and the whole and the next part is yeah, this is the rear. Next is the very rear member. And the yes, yes, yeah, yeah, yes, one, yeah, the one is yeah, and because you rotate, you can get the yeah, and that is the rear. Oh yeah. Yes, more that more or equal one. Right? And now have this and this is the yeah.
So the range is -4 to -8.
Yeah.
This one is 16, right? 16. One number.
Here 16. 16 is what? Here is 16. What is the 17? The problem here, the problem here. And I think here, here, right? Around
No, this book is like, what this is supposed to be.
little look, right? A little look. Okay. Like that. Line and this line. Plus the one. This close one. That's line. This one. So I see one part for the people that did in four is for six, right? For the static six the source is the large. One rate large for the static. I feel it. I feel it. To the whole cover. Then the whole, and this is the maximum. This is the or equal. One is, I mean that is low. The maximum is that.
H plus H. Slum H.
And then,
If you say this,
when you choose this one,
this condition, you need to take the same. Solution of A or C.
okay, that's okay. I think you always choose this one, and then you Yes, the rear maximum and the rear inferior, maximum area and maximum inferior. Check whether the maximum in range is here or not. If in range is okay, right? If not, yeah. Yeah, yeah. You give the yeah.这里也是呀，这个意思，这个意思，这里还是这里，呀，那个呀，对吧？那你是平平。
The range is -1 to -10. And
You should calculate the maximum experience and maximum experience. Calculate the maximum experience, the maximum experience. That is weird, yeah. The real value. It's appearance, okay, but the transition. Oh, yeah. Problem. The can get this one right, and then you learn to think about it. Oh, this is the shot. The zone is a high pressure, right? Maybe the whole. The pressure is 7 or 6. Usually it's 7. It's 7. The I7 has 7 pressure, which is right. The EI and the EM. This is interference that is not us. Condition. Okay. And then we should do this one and this one, right? And then this one. Yes, yes, there is and the next
yeah, my one is satisfied.
Yeah, yes. Right. And because this is transition, and there are transition. For the Saturday, condition. I'll give it. This one. Here is here. Here. But the yes from the table, that's the real value. So the yes is is smaller than 1, we'll change the case. Which one? So yes. What? Okay, continue. Explain to everyone, okay? I know, and everyone can get this one.
On the ninth line.
0 with 11, right?
Yeah. Oh, it's on.
Okay, everyone get this one, right? No one got this one? No. Okay. But so the basic 6, 11, and the maximum clearance equals this is the maximum, right? Maximum. The maximum is ES equals EI, right? This is right. Right?
Yes.
Maximum.
Yeah.
This is the maximum. I mean this one. This is the 12. Sorry, minimum. Oh, minimum clearance. Sorry. Minimum clearance. Right?
Maximum clearance.
What is less max?
But the less.
Yes.
Okay.
Yeah.
Right? So this Y maximum. This is E.
It's like that, the formula is wrong.
It's X max.
Huh?
It's the formula.
Formula.
X max, not minimum. X max.
This is interference. Oh, sorry. Radical. Sorry. This is this one.
No, that you change. Put like that. Let's go.
The maximum clearance.
Yes.
I mean, we designed this one. This is the maximum this is the maximum clearance. This is the maximum interference, right? We designed it like this one, right? Right? Is the we'll change another way. TS. This is the maximum and plus the minus the minimum, right? Equals the smaller or equal, right? Equal the y x maximum minus y y interference maximum, right? So this is
Yeah.
So if the TH equals TS, so this is for the IT smaller larger 8, right? TH equals TS. This is for the larger the 8, right? So okay, if from this one IT equals 30, right? TH.
Okay.
So we can take the table. Take the table. We choose the IT 6, right? When we can get the 6, we need to think about that. The whole maybe is the 7, right? For the combo design, because this is the high pressure, right? So we choose the whole is at 7. TS, right? We need the TS. Oh,
Same.
the same. Because this is TH and TH is the same. We choose this is the roundly choose the IS, the TS, the TS is the 6. TS the 6 or TH, roundly think about it. You mean that the grade is 6 or 7, right? And then we choose the shaft is the 6 and the hole is 7, right? we choose the sixth. The shaft is the sixth, but it's a high pressure. I will choose the hole is 7. When we choose the sixth, it's okay, and then we back to that if the range is like this one. So we can choose large the range. Mostly the common design, the shaft is 6, the hole is 7. Right? Because this is a high pressure.
Yeah.
So from the 6, we can get this one. This is the shaft is 0. The 6, this is 6 is 11, right? But the T 6 equals what? 11? Oh, 11. Okay, so this is minus 11, right?
Yeah.
And then this is the transition feet, right? Transition feet, right?
Yeah.
You can back to the figure 28. You get the whole. This is transition. The transition is like the KMN is the transition. Right? Yes. You choose KMN. But the H is give me.
Yeah, follow game.
Follow me. The KM. So that's for the whole like this one. Transition is this one, right? So this is the ES, this is the EI. So we can find from the table, we can get the ES. Maybe you can ask why we can get the EI. Because this is transition. Transition it means that this one is close to the 0, 9. So we can from the table we can get the ES, right? The ES, how can we get the ES? The maximum. The EI minus EI equals
Yes.
maximum X maximum, right? So the ES equals this EI 0. And this is the maximum. So his maximum is 11. So it's equal or smaller 12, right? So ES 1, right?
Yes.
So you from the table you can check which word is close to the 1 from table. For the whole 16 is you can get minus 7 at data.
Yes.
Data is 7. 7 is 7, right?
Delta is
So we can get is
Seven.
delta. So data is 7. So this is 0. So like this is 0. 0 is like this, right?
Mm.
So it's 0. So EI is this is IT7, right?
Mm.
This is IT6. So for the whole is IT7, right? IT7 is from the table 2.4 is IT7. It's 18, right? So it's minus 18. This one. And you get this one. And then is number, right? And then you check. This is the H6. The 18. This is M. And 7. The M. The symbol fit. The fit. The fit symbol you got that, right?
Yeah.
The M because it's 0, so it's M7, right?
Yeah.
And then you get the right result, right? And then you check. This is the maximum is maximum is ES minus EI. 这个 maximum x maximum is ES minus EI equals ES minus EI 11, right? In their range, right? So y maximum equals EI minus
Yes.
ES is minus 18, right? This is the range, so this is right. Thoughts?
Yes. So I should not tell M.
Huh?
Not tell.
Not F, yeah, it's M. It's F, let me see this F. Not F, F maybe is not the transition speech. Well, the number. F is the clearance. You can check the page 28. The figure 28. The F is the clearance feet.
Oh shit. Let's see what it states.
Huh?
Yeah, what is this now share? I want to take a picture, but
Picture what?
what is this?
This is the whole.
Age. Okay. No, the whole. The whole. The one just has its age.
Whole is I7.
Everything, Baba. No, the 7 the whole.
Thoughts? Next class.
One is down.
Get you exercise.
Here at first you find ES, right?
Yeah.
If I want to find EI at first, so I need to take this formula. I need to change this formula. Like
You mean that you need to find the ES first, and we this equal.
I want to find this ES at first.
Yeah.
Can
Why?
I do it?
You will want to find the ES first, right?
Here you go to EI. At first you go to ES and then you go to EI, right?
Yes.
I want to get EI at first and then ES. Can you do
You
it?
can't do get the EI first because this is the
Maybe you.
transition, right? Transition fit. You can get the table 20, the figure 28. This is the basic line. Because you need to find the fundamental deviation first, and then you get the grade, the tolerance grade, get another word, right? This is the real steps, right? So the first thing you need to design which one is the fundamental deviation.
So how you get this this ES is the fundamental deviation?
Yeah, I just explained this one. So this is the transition, right? This is the H. This is the H here. The transition is the KMN is the transition. KMN transition. This is the fundamental line is here, right?
So it's 0. So
It's here is the ES.
Yeah, this ES. So this KMN for
Yeah.
KMP ES equals 0, 0, 0, 0.
Yes, not equals 0, 0, 0. Okay,
Okay.
0, 0 is for the whole basic is 0.
Yeah, that's it.
Yeah, so this is the KMNP. We just get the ES from the table because this is the deviation line. The fundamental deviation. The fundamental deviation is close to the 0 line.
So if you follow this figure, so why you did these things? You can directly write ES equals 0.
Why can you from table? Because this one is right? You get this one.
Yeah.
This is right? And this is the one, right? And from the table, because the fundamental deviation value, we check that from the table, right? So and then we can check the table.
I understand.
You're asking, I know you are trying to say why we can't find EI first. Because every time before you check, before you find, you have to find which one is the fundamental line close to
Okay, so which one is
the line.
fundamental line?
This one,
If you need to follow this figure, which one is the fundamental line. So why you need this math? Just
Because
just write ES equals 0.
no, because
No, there-
because
this is not-
because ES
Oh,
is
this
not
is
the
yes.
fundamental line. You understand?
This is not fundamental.
ES is the fundamental line, but
Yeah.
it's not always that zero. If you just write zero and it's not zero, what will you do?
No,
That's
it's zero.
calculate.
It's zero for it's zero for K, M, and
No,
No.
no, zero for the KMN,
You
okay?
said-
I know, I didn't say it.
Not always.
The
Only
KMN,
always.
I mean the KMN is the transition fit.
Yeah.
When the H, when the H, yeah, when is the shaft basis.
When is the shaft is basic?
If sharp
Yeah.
basis is that one is zero, the initial zero. You don't get
So the first thing is to tell which one is the fundamental deviation. So the ES,
well, she didn't tell us. I didn't know. I was calculating EI. I spent.
Even I tried at first ES, then I go.
No, I was calculating
it's
EI.
hard to find the ER, right?
Yeah.
Not right. I'll continue.
No, she times 12.
They have three figures. It's very quick, okay? And so design is enjoy, okay? The power drawing is this is simple, okay? And when you power drawing, it's just like to figure, to write like this one. It's fine, it's okay. And assembly drawing like this one. 3, HC, H7, 3, 6. You have already draw that one, right?
Last semester we didn't understand.
Because now you understand. So it is the feature, the feature type.
Yeah.
Okay. And then whether it's up to understand the actual size is 105, which is designated 111 and 100. So this one is okay. Like this one. Well, it's fine. So this is like is tell you that when you draw the figure and you can to rotate like this one, it's okay. Okay, class over. No, sorry. Question, homework, okay? Homework is 2 page 52.6. And then you can get the homework is very important, okay? The page. You can to find, you have the steps, okay? You need to have the steps. How do you choose the symbol? Everyone got the homework?
Yes.
Easy. Okay, easy.